So our next chapter is ammonia. Again, we will talk about the laboratory preparation of ammonia, some of its important properties and certain important reactions. So let's start with the laboratory preparation. So we can prepare ammonia by three different methods. Two will be laboratory preparation and one is its manufacture in large factories. So first of all, we can prepare ammonia by using ammonium chloride. This is the easiest and the cheapest method. So what is done, ammonium chloride and calcium hydroxide is taken in a particular ratio. This ratio is very important. Why? We will learn in the next page itself. So the ratio is 2:3. So what is the reaction? NH4Cl plus CaOH whole twice, it will give you CaCl2 plus H2O plus NH3. Ammonia gas is released. So as you can see in the experimental setup, the round bottom flask in which the reaction is occurring, it is a little tilted. Why is it tilted? Because the water formed in this reaction will start cooling when it will reach this neck portion of the flask, so that the water doesn't go back into the reaction. Therefore this flask is tilted a little bit. So whatever water will be formed, it will be formed in this region only. It will not go back again, because if it goes back, it can break the glass apparatus. As a result, we are just tilting the flask in such a way. And the gas, the ammonia gas, is coming through this pipe and it is moving into this drying jar, you can say. Again, this ammonia might consist of small amounts of water vapor that is removed by using quicklime or calcium oxide. Very important. In each and every compound which we will study now, we have to remember what is used and why it is used. So calcium oxide is used or quicklime is used for drying ammonia, and then the dried ammonia is moving to this flask. So why do we use quicklime? Why don't we use any other drying agent? Again, the same reason. If we use any other drying agent such as concentrated sulfuric acid or phosphorus pentoxide or calcium chloride, ammonia is basic in nature, so it will react with all of these. But we don't want any reaction, we just want drying. Therefore we are using calcium oxide. Next, how is ammonia collected? In hydrogen chloride chapter, we learned that hydrogen chloride was heavier than air, so it was collected by the upward displacement of air. Air was moving upwards and hydrogen chloride was moving downward. But in this case, since ammonia is lighter than air, it is collected by the downward displacement of air. So air will move down and ammonia will move to take its place. Ammonia will be formed over air, but in the previous case, hydrogen chloride was forming below air. So again, another reason why ammonia is not collected over water, because it is highly soluble in water, just like hydrogen chloride. As a result, when we will mix ammonia with water, we will use the funnel arrangement once again. Calcium hydroxide is used in this reaction because it is cheap, and also it does not absorb water from the atmosphere. It is not deliquescent. All the other alkalis are generally very much deliquescent in nature, but calcium hydroxide doesn't show this property. Instead of using ammonium chloride, we could have used salts such as ammonium nitrate and all, but none of these salts are preferable. Ammonium nitrate is explosive in nature, so the reaction will be very exothermic. Also, there is another salt, NH4NO2. This will not form ammonia. So we cannot use any of these salts. We have to use ammonium chloride only. Also, why we have taken that particular ratio? We know NH4Cl, ammonium chloride, is a sublimable substance. If you place it just like that, it will get converted into vapor. So that this sublimation process can be reduced, that's why we use a larger amount of calcium hydroxide. That's why the ratio is 2:3. So this is the first method by which ammonia can be prepared in the laboratory. This is a very cheap method and very preferable. Now the next method is preparation of ammonia from nitrides, from metal nitrides. This is a very costly process because metallic nitrides are quite expensive. So let's see what is the reaction. Magnesium nitride, Mg3N2, it will react with warm water. It is not just simple water, it is warm water. It will produce magnesium hydroxide and ammonia gas will be released. The same experiment can be done by using aluminium nitride also. So Aln plus H2O, it will give you aluminium hydroxide and ammonia gas will be released. But this method is not generally preferred. Again, like I told you, if you want to mix ammonia with water, it has a very high solubility. That's why funnel method is used. As you can see, the ammonia which is formed after the reaction of ammonium chloride and calcium hydroxide, it is coming through that pipe and it is moving to the funnel. Again, due to the pressure difference and due to the solubility, a small part of water will move into the funnel. It will mix up with the ammonia present in the funnel and it will come back again. It will fall back again in the beaker. This process will continue till the entire beaker now contains ammonia mixed with water. So the same type of reaction or the same type of procedure like we learnt in the previous chapter. Next is the manufacture of ammonia on a large scale basis in factories which produce only ammonia, and this process is known as Haber's process. Very important. You have to learn what are the things used, why are these things used, what are the conditions that have to be followed while performing this procedure, everything. So the reactants are nitrogen and hydrogen. Obviously, in order to produce ammonia through Haber's process, we will use the normal method. Nitrogen plus hydrogen will give you ammonia. So if you balance the equation, you can see that we have 1 amount of nitrogen and 3 amounts of hydrogen. So the ratio is also same, 1:3. So how are these nitrogen and hydrogen gases, how do you obtain it? Let's see. Nitrogen is obtained by the fractional distillation of liquid air. In air, we know nitrogen is a major component. So from air, by the process of fractional distillation, we are getting nitrogen. And hydrogen is obtained from water gas. Water gas is actually a mixture of two gases. It is not necessary, you don't have to remember. But from this water gas, we are getting hydrogen by the process known as Bosch's process. So you have to just remember from where we are isolating nitrogen gas and hydrogen gas. So the reaction is nitrogen plus hydrogen will give you NH3 and heat. It is an exothermic reaction. It is also a reversible reaction. So don't just put a single arrow, you have to put a double-sided arrow. The reaction is reversible, exothermic, and proceeds with a decrease in volume. So what are the temperature and pressure? The temperature is 450 to 500 degrees Celsius. The pressure is above 200 atm, very huge amount of pressure. You have to remember the pressures and temperatures also. The catalyst is finely divided iron. We break the iron particle into very fine parts so that the surface area for this catalytic process increases. We will learn about it. Promoter used is traces of molybdenum or Al2O3. So you have to remember this also very nicely. So the 4 conditions, the 4 types of requirements, you have to remember it by heart. So why do we use these things, or how do we use these things? Let's see. The reaction is exothermic, hence low temperature will favor the synthesis. However, at low temperature the reaction proceeds slowly. In practice, the optimum temperature has been found to be in the range of 450 to 500 degrees Celsius. So the reaction is exothermic in nature, heat will be produced. So even if you apply a small amount of heat initially, the process can continue, but it is favorable to use 450 to 500 degrees Celsius for this process to go nicely. 4 volumes of reactants produce 2 volumes of product, hence high pressure favors the formation of ammonia. As you can see, in the reactant side we have 3 plus 1 4 volume, but in the product side we have only 2 volume. That means initially it was 4 volume, now it is 2 volume. That means volume has decreased. Volume decreases means high amount of pressure is necessary for this procedure, because high amount of pressure means you are compressing the volume and you are decreasing it. You are squeezing the volume into a smaller space. So the pressure required is more in this case. So the pressure optimally is 200 atm. Catalyst and promoter, like I told you, catalyst is finely divided iron. We use finely divided iron so that the surface area increases and the process can happen a little more quicker. Also, the promoter molybdenum is used, or Al2O3 is used. Promoter is used to make the catalyst work even better. To increase the efficiency of the catalyst, we use this promoter. Since the reaction is exothermic, the heat evolved further maintains the temperature. External heating therefore is not required after the reactants are finely heated. So initially we will apply a temperature of 450 to 500 degrees Celsius. But as the reaction continues, the heat produced in the reaction is sufficient enough to produce more and more of ammonia. You don't have to heat anymore later on. So very interesting thing. The purification of nitrogen and hydrogen is necessary because impurities like carbon dioxide, carbon monoxide and traces of sulfur compounds poisons the catalyst. The removal of these catalytic poisons from the nitrogen and hydrogen is very essential. So since we are obtaining nitrogen and hydrogen by two different methods, it is also necessary that this hydrogen and nitrogen is completely purified, because there can be substances like carbon dioxide, carbon monoxide or sulfur compounds which can poison the catalyst. The catalyst will not be able to work nicely. So we have to remove these type of catalytic poisons from the reactants very nicely initially only. So these are the conditions required for Haber's process. This is a very important process, because from here lots and lots of questions can be formed. Talking about the fountain experiment again, in the previous case we saw that a red fountain was formed because hydrogen chloride was acidic. In this case, since ammonia is basic in nature, when it dissolves in water, it will form a blue fountain. The reaction is same, as you can see in the right hand side. This is how the fountain looks. So instead of using blue litmus solution in the beaker, in this case we will use a red litmus solution, and because of the pressing of the dropper, due to the pressure difference again, the litmus solution will move into the flask, and in the flask we have ammonia, and that ammonia will readily mix or dissolve in that water, in that solution, and it will form a blue coloration. So it is like a gush of water, it is like a fountain once again. So question can be asked, how can you differentiate between hydrogen chloride gas and ammonia just by seeing the color of the fountain experiment? For ammonia it is blue, for hydrogen chloride it is red. So here are a few reactions, a few of it you already know and a few of it are new to you. So when ammonia, NH3, when it is dissolved in water, it becomes the aqueous solution of ammonia, and the aqueous solution of ammonia is nothing but ammonium hydroxide. So let's see what is the reaction. NH3 plus H2O, ammonia plus water, it will give you NH4OH, ammonium hydroxide. And ammonium hydroxide's reaction you have studied in analytical chemistry. It will react with different metal ions to produce different colorations of the precipitate, through which we can identify. So these reactions are given at the bottom. It is self-explanatory because you have already studied about this in the previous chapters. So now let's see how this ammonia solution, the solution of ammonia, it reacts with acids. So NH4OH, when it reacts with HCl, it will give you NH4Cl and H2O. You will get the ammonium salt and water in all the cases. When ammonium hydroxide reacts with nitric acid, it will form NH4NO3, ammonium nitrate and water again. Similarly, when it reacts with sulfuric acid, H2SO4, we are getting ammonium sulfate, NH4 whole twice SO4, and we are getting water. So these are the few reactions. Which are known to you or which are easy to remember. So now we are going to learn about 4 very important reactions of ammonia. These reactions are very, very important from the exam point of view also. So first of all is the reaction of ammonia with oxygen. Ammonia is not a supporter of combustion, but if it is burnt in oxygen, it will burn with a yellowish green flame. It will not generally allow combustion to occur, but it can burn in itself. So what is the reaction? NH3 plus O2 gives N2 and H2. So nitrogen gas is formed and water is released. So the process is done in a special type of tube, as you can see. A white glass tube is fitted with a cork carrying 2 tubes. So there are 2 tubes inside a larger tube, as you can see. From one of the tube, ammonia gas is entered, and from the other tube, oxygen gas is entering. It's not that we can just mix it up in a normal flask. And after they have mixed, then what is happening? A lighted match is applied. A match which has been lighted, that is given. Because of that heat, this reaction will occur. So we can see that inside the flask, the ammonia will start burning with a yellowish green flame, light yellowish green, and water vapors will be produced. You can see the cooled down water droplets at the upper portion of the larger tube. From this reaction, we can very easily understand that that ammonia consists of nitrogen and hydrogen, because nitrogen has been released and the hydrogen which is produced, that is combining with oxygen to form water. Mixture of ammonia and oxygen is explosive and therefore dangerous. Since if we just mix up nitrogen and oxygen, it is very, very explosive. Even if a small amount of heat is given, it will start burning. As a result, the experiment has been done inside a closed tube. Next is the catalytic oxidation of ammonia. As the name suggests, ammonia will be oxidized but in the presence of a catalyst, because if catalyst is not applied, the temperature required for this procedure is very high. Even on applying a catalyst platinum, the temperature is 800 degrees Celsius. So it's a very high temperature. So what happens? Ammonia reacts with oxygen to give nitric oxide and water. The previous one was just burning of ammonia in oxygen, but this is the catalytic oxidation. So the products formed are also different in this case. As you can see over here also, we have not taken any open flask. From one end NH3 is getting applied and from the other end O2 is getting applied in a tube. Inside the tube we have platinum, which is the catalyst, and heat is given. So what are the things which are formed in this case? NH3 plus O2 in the presence of platinum and at a temperature of 800 degrees Celsius. You have to remember the temperature and the catalyst used for this reaction. We get water, we get nitrogen monoxide in this case. In the previous case we got nitrogen gas, but here we are getting nitrogen monoxide and we are getting heat also. This is again an exothermic reaction. Next, this NO, this nitrogen monoxide, it will react with the leftover oxygen. So we will get nitrogen dioxide. Nitrogen dioxide is characterized by its brown color. So we will see fumes of brown gas forming. Reddish brown vapors of nitrogen dioxide are seen in the flask. As you can see in the right hand side, there is a round bottom flask. So in that flask you will see brown fumes of nitrogen dioxide. The platinum continues to glow even after the heating is discontinued, since the catalytic oxidation of ammonia is an exothermic reaction. So initially when we are starting the reaction, since the temperature is 800 degrees Celsius, a very high amount of temperature, so the platinum will start glowing red. It will become reddish hot. So even after the experiment has been completed, the platinum will still continue to glow for quite a long amount of time, because a lot of heat is released in the reaction. The reaction is exothermic. So the platinum will cool down after quite a good amount of time. So this is the catalytic oxidation of ammonia, and the previous one was just the reaction of ammonia with oxygen. Now talking about the reduction of chlorine to hydrogen chloride using ammonia, basically reaction of chlorine with ammonia. Here we can have two types of reaction. In one case chlorine is in excess and in the other case ammonia is in excess. So don't get confused in which case what are the products formed. So let's see about initially when chlorine is in excess, what happens. When chlorine is in excess, then the products are hydrogen chloride and a yellow colored highly explosive liquid called nitrogen trichloride. You have never heard about this chemical earlier, so this is a new thing completely. So whenever chlorine used in the reaction is excess in amount, so what is formed? HCl is formed, hydrogen chloride gas is formed. Along with that we are getting a highly explosive liquid. It is not a solid, it is not a gas, it is a liquid. It is called nitrogen trichloride, NCl3. So this happens when chlorine is present in larger amount. Now what happens if ammonia is present in larger amount? Let's see. NH3 plus Cl2, initially it will give nitrogen gas and it will give HCl. This HCl will again react with ammonia. So we are getting NH3 plus HCl, it will give you NH4Cl. So if you combine both the reactions together, you are getting NH3 plus Cl2. It will give you N2 and NH4Cl, because HCl is formed in the product side once and that HCl is used in the reactant side once. It is getting cancelled out. So you can remember the final equation that NH3 plus Cl2 will give you N2 plus NH4Cl. You don't have to remember the middle equations. So this is the product form. So in case when ammonia is in excess, we are getting nitrogen gas and ammonium chloride. But when chlorine is in excess, we are getting HCl gas and NCl3, which is an explosive liquid. This NH4Cl, which was formed in the first reaction, like I told you, NH4Cl gives white fumes. We have studied in hydrochloric acid, hydrogen chloride chapter also, and we have also studied at the beginning of this chapter. So we can understand that NH4Cl is formed by seeing the white fumes. So from these reactions we can understand one thing very well, that chlorine has a very high affinity for oxygen. That's why chlorine is for hydrogen. Chlorine is combining with anything which has hydrogen in it. You can see HCl is formed, NH4Cl is formed. So chlorine has a high tendency for reacting with hydrogen. Also ammonia is a reducing agent. This is a very important property because it is reducing chlorine into hydrogen chloride. Reduction means addition of hydrogen also. So hydrogen is getting added to chlorine. That means ammonia is helping this process. So ammonia is a reducing agent. Next is another reaction of metallic oxides with ammonia. There are only two metallic oxides which can react with ammonia, and that too under certain conditions. Let's see. So when ammonia reacts with copper oxide is a black colored solid. It will form copper. Copper is a reddish brown solid, and it will form water. It will also form nitrogen gas. In most of the cases, we are seeing that nitrogen gas is being produced. Similarly, even if in place of copper oxide you are using lead oxide or lead monoxide, the same reaction is happening. So lead monoxide plus ammonia, it is giving you lead, then it is giving you water, and nitrogen gas is released. So since nitrogen is lighter than water, so as you can see, nitrogen is collected over water. You can see in the figure below, nitrogen is collected over water. So this is done in this case. So these are the few reactions which you have to remember by heart, because these are the only reactions which are new and very, very important.